Let's take a look at example 5. We're asked again to solve for triangle ABC if we know that A is 40 degrees, side A is 54, and B is 62. Round the lengths of the sides to the nearest tenth and the angle measurements to the nearest degree. With the starting information, we have side A, side B, and angle A. That's two sides and the non-included angle, so that's SSA again. This could put us in the ambiguous case of the law of sine, so we want to calculate the value h to begin. H is equal to b times the sine of A, which would be equal to 62 times the sine of 40, which gives us an h value of 39.9. Because A is at least greater than or equal to h, that means that there will be a solution. So there will be a triangle that will make the given information work. However, because A is also less than B, A is 54, B is 62, that means that we're in a situation where there actually would be two solutions. So with the starting information, there's actually going to be two unique triangles we can form with the starting information. And then our goal, of course, would be to go ahead and solve for those triangles. So the first one, I'm just going to call this one triangle 1. And let's suppose we're going to label the sides. We have A, which we already know, B, which we already know. So A is 54, B is 62, and I'm going to call this one C1. We know angle A is 40 degrees. We don't know angle B. Let me call that B1. And we don't know angle C here. Let me call that C1. We will have a second solution. Let's call this one triangle 2. We'll have the same starting value for A, same value for B. We will have a presumably different length for side C2. Angle A will still be 40 degrees. We'll have a different angle for B. And then we will have a different angle for side C3. To begin, let's start by solving for angle B in this case. So one of the things that we know is that the ratio of A to the sine of A would be equal to the length of B divided by the sine of B. With a little bit of algebra, we can solve this for sine B. I'm going to skip that step. You'd multiply both sides by B. You would then get rid of the fraction 54 over sine of 40 degrees, and you would find this. The sine of B will be equal to 62 times the sine of 40 degrees divided by 54. Alternatively, an easier way, and perhaps maybe a better way to explain it, is you could always cross multiply and divide. You would take 62 times the sine of 40, divide that by 54, and that's what you would get for the sine of B. We can plug this into our calculator. (62 sine 40) divided by 54 would give us about 0.7380. And then to solve for angle B, you can do the sine inverse of both sides. So one value of angle B that would work is going to be about 48 degrees. So let's call that B1. It's also possible, coming over here, that we could have created a second angle, B2, that would be an obtuse triangle, where angle B2 could instead be 180 degrees minus that 48 degrees. which would be 132. And the reason why that works is with an angle B equal to 132 degrees, angle A is 40. That still leaves us with extra room or an extra measurements to complete a third angle, which we would call C3 in that case. So typically, this is what the two solutions case is going to look like. Whenever you know that there's two solutions, starting with side A, side B, and angle A, begin by setting up a law of sines to solve for angle B. Like we did in the last example, you'll get one value for angle B, which will come directly from the sine inverse. That'll be angle B in your first triangle. The second triangle will have an angle B that's found by taking 180 minus the other one. So 180 minus 48 produces 132 degrees. That's going to be our obtuse triangle solution. And then from there, we can finish it up by solving for angle C and side C in each case. And I'm not sure why I'm calling this one C3. That's angle C2. Should be capital C2. Let's finish this one off. So for the first triangle we're looking at, I can now solve for side C1. That's going to be angle C1. Take 180 minus the sum of 40 and 48. And that would give us 92. We can now solve for side C1. Side C1 is going to be equal to, we have 54 divided by the sine of 40 degrees is going to be equal to side C1 divided by the sine of 92. Cross multiply and divide, you would get that C1 is equal to 54 times the sine of 92 degrees divided by the sine of 40. And so C1 is equal to the nearest tenth, it's going to round up to 84.0. So those give us the values for the first triangle. Similarly, we can solve for triangle 2. We would do 180 minus 40 plus 132. That would give us angle C2 as 8 degrees. To solve for side C2, set up a law of sines. 54 divided by the sine of 40 degrees would be equal to side C2 divided by the sine of 8 degrees. Cross multiply and divide, we would see that 54 times the sine of 8 degrees divided by the sine of 40 degrees is the value of C2. Which would give us a length of 11.7. So side 2 would have a length of 11.7, and those would be the two solutions. We get two distinct triangles that would solve for the given information. The last thing we're going to look at is the area of an oblique triangle. If we have a right triangle, we know that the area is equal to 1/2 base times height. If we don't have a height or a right triangle, we can still find the area by taking 1/2 the product of two sides times the sine of the angle that forms those two sides. For example, if I go back and pick on this very first triangle right here, if I know side B, which is here, I know side C, which is here, the angle between those two is the angle formed by those two sides. That would be angle A. I can find the area by doing 1/2 B times C times the sine of A. Conversely, if you knew side A and side B, then you would need to multiply it by the sine of angle C times 1/2. And then if you had A and C, it would be 1/2 the product of A and C times the sine of B. Let's take a look at example 6. They ask us to find the area of a triangle. We know side B, we know side C, and we know the included angle that forms those two sides. So we should be able to find the area by using the formula from above. It's 1/2 the product of the two sides times the sine of the included angle. This is going to be equal to 1/2 times 10 times 24 times the sine of 62 degrees. And this would give us an area that's going to be equal to about 10.6. The units were given in terms of meters, so this area would be square meters.